Hello everyone. In this video, we will understand one of the lead code question, and the question number is 238, and the question says product of the array except self. So this is the problem statement of this given question. So let's understand this question with the help of example. Let's understand what this question means and how then we can solve this question. Okay. So the question says that we are given a array. Okay. And then we have to find a output array, or you can say we have to find a resultant array such that there are some condition applied. Okay. So what is the condition? I will tell you with the help of example. Okay. So the question is, we are given this array. Okay, let's say we are given these elements 2 4 3 5 3. Okay, so these are the indexes 0 1 2 3 4 of the array. Okay, now for this question, this is the resultant array as the output. So the question actually says ki we have to find the output array in such a way so that what will happen, for example, this is the zeroth element, that is 2. Okay, now what we have to do in the resultant array, that is in the output array at the zeroth position, what should come? Actually the product of all the element except this element. Okay, so at zeroth element in our given array 2 is present. Okay, so leave this element and find the product of all the remaining element in the array. So 4 multiply 3 multiply 5 multiply 3. Okay, so actually the product of 4 into 3 into 5 into 3, it is actually 180. So here at zeroth position I will store 180, that is product of all these elements, right? Okay, now if we come at the first position. Okay, so here what should I keep? I should keep the product of all the array elements except this element. That is, I should find the product of 2 multiply 3 multiply 5 multiply 3. So 2 multiply 3 is 6, 6 5 is 30, and 33 is 90. Okay, so I have not multiplied this 4. Okay, so I have done this thing 2 into 3 into 5 into 3. Okay, so the answer is 90. So at one position I should keep 90. Okay, same way if we talk about at this second index, then I should multiply 2 into 4 and then 5 into 3. Okay, the 2 multiply 4 multiply 5 multiply 3, it is 120. Okay, 2 4 is 8, 8 5 is 40, 43 is 120. So here 123 is kept, and accordingly I have put here this 72 is the multiplication of 2 4 3 and this 3. Okay, and this 120 is the multiplication of all these elements. Okay, not this element. Okay, 2 into 4 into 3 into 5. Okay, so you have to leave that particular element, okay, at that index. Okay, if you are finding the product at fourth position, then leave that element and find the product of all the remaining element and keep the answer in the resultant array. Okay, now this is the another example. For example, in our given array 0 can also be present. Okay, in that sense also, or in that example also, our program should run correctly. Okay, so again with the same logic, if we talk about at this position, okay, here this 0 is the product of this 1 0 minus 3 minus 3. Okay, so I will not multiply this element. Okay, because I have to leave this element because this is given in the question. Okay, if you are at the ith position, okay, and you have to find what will be the answer here, so you have to leave this ith element and find the product of all the remaining elements. Okay, so 1 multiply 0 is 0, 0 multiply something 0, and 0 multiply something is 0. Okay, so basically you multiply 1 into 0 into minus 3 into minus 3. Okay, so basically if 0 is present in the multiplication, then final output will be 0. Okay, so here 0 will be present. Okay, now what will come here? So here this 0 is the multiplication of what elements? This. Okay, I will not keep this, then this, then this. So all these four elements, minus 1 into 0 minus 3 into 3. Again 0 will be there because 0 is multiplying in this sequence. Okay, again here what will be the answer? So multiplication of these minus 1 into 1 and minus 3 into 3. Okay, so if you multiply all these four elements, we will get 9. Why? Because minus 1 into 1 minus 1, minus 1 into minus 3 is positive 3, and positive 3 into 3 is 9. So 9 will be kept. And again here 0 will be kept. Why? Because I will not multiply this element, but I will multiply 3 into 0 into this into this. So again 0 will come. Okay, because multiplication of all 3 into 0 into 1 minus 1 will be 0 because 0 is there. Okay, accordingly this will come. Okay, so basically they have said we have to solve this question, okay, in this time, that is O time complexity. Okay, and they said do not use the division operator. Okay, and the follow-up question they are saying is that can we solve this question in O1 space complexity? Okay, and they also said ki if you are taking the extra output array, okay, to store your result, then we are not counting the space of that array. Okay, so here we have kept this array, okay, of n size. Then also we will say our space complexity will be O of 1. Okay, so I hope you have understood the question. Now let's see how we can solve this question. Okay, so basically I will tell you all these solutions. Okay, we will see first the brute force, and then we will see how we can solve it using the division operator, and then we will see the solutions without using the division operator. Okay, so in this we have two solutions, okay, using two extra arrays, and another is without using any extra two arrays. Okay, we will not use those extra arrays, we will just use the output array, that is the resultant array, okay, to store our answer. Okay, so this will be our, you can say, in most optimized you can say solution out of these all these solutions. Okay, so let's see one by one and start from the brute force approach. Okay, so basically at 0th position what we have to do, we have to find the multiplication of all these elements 4 3 5 3. Okay, we do not have to multiply 2. So basically what we will do in one of the loop, what we will do, we will find the multiplication of these elements 4 3 5 3. Okay, so what we can do is we can take a product variable, okay, and then we can say 4 multiply 3 multiply 5 multiply 3. Okay, so we can take a for loop and we can just multiply all these elements. Okay, and then here we can store the answer. Okay, so 4 3 are 12, 12 5 are 60, 63 are 180. Okay, so 180 will be kept. Okay, now again we will come at this position. Okay, and then what we will do, we will again run a loop, okay, from 0 index to the last index. Okay, and then we will multiply all the element except this element. Okay, so what we will do is we will just put up one condition that when we are coming at 1th position, okay, then we have to leave this element. Okay, so we will multiply 2 3 5 3. Okay, so basically here we can keep the answer 2 3 are 6, 6 5 are 30, 33 are 90. Okay, and same way when we will come at this index, okay, then we will just leave this element, okay, by putting one condition in the if. Okay, and we can multiply 2 4 5 3. Okay, so 2 4 is 8, 8 5 is 40, 43 is 120, and so on. So if you see here, we can just take two for loop. Okay, so this inner for loop is find the multiplication of the element. Okay, and this outer loop is actually iterating through all the positions. Okay, so for I equal to 0, okay, we say product is actually 1. Okay, and then we are coming inside and this is actually finding the product. Okay, and here we have kept one condition, okay, that if the current position, okay, is not equal to j, okay, then only we will find the product, otherwise we will leave that element. Okay, so this is actually helping us that please leave the element at the current index. Okay, so if you see, if I is 0, we are coming here and then we are again starting the loop from 0 to, okay, n. Okay, and we are saying, okay, 0 is not equal to 0. So initially 0 is equal to 0. So we will not find the product. Okay, that is this a of I, that is this element, this 2 will not be multiplied. Again we will go and j is 1. So now j is 1. So 0 is not equal to 1. Okay, so now I is 0. Okay, so now 0 will not be equal to 1. Okay, so we will multiply what? We will multiply this 4. So 4 will be multiplied with product. Okay, so as you know, in the product, when we are finding the product of the element, then it is better to take the initial value of the product variable as 1. Okay, if we take it as 0, then everything will be 0. Okay, that's why we have taken 1. Now 4 will be multiplied. The 4 1 ja 4. Okay, so in product 4 will be present. Okay, so we have multiplied this and then again we will go, we will fetch this element. Okay, and this is at the second position, so j is at the 2. Okay, so 0 is not equal to 2. Again 4 will be multiplied with 2. So 4 will be multiplied with 2. Okay, this a of I is 2. 4 to the, sorry, this is 3. Okay, this is 3. Okay, so 4 3 is 12. Okay, so 4 multiply 3 is 10. So accordingly, this loop will find the product of 4 into 3 into 5 into 3. Okay, after finding the answer, that is 180, which is stored in the product, at last what we will do, we will store this 180 into the result of I. I is initially 0. Okay, so 180 will be stored. Again, I will be 1, and now this loop will again run from 0 to n. Okay, so this condition will be false at what point? Okay, when we will come at this. So when j will be 1, then 1 not equal to 1 is false. Okay, so we will actually leave this element. Otherwise, from starting 0 to last index, we will find the product of all the elements. Okay, so I hope you know what is the time complexity of this question. Okay, so if we find the t of n, what will be time complexity? So it will be order of n squared. Okay, because this is of order of n, because this is iterating from 0 to n, and again this is also iterating for all the elements. Okay, this is of order of n. So order of n into order of n, it is n squared. Okay, space complexity. Okay, if we talk about the space complexity, it is simply order of 1. Okay, because we have just taken this extra array, that is the result array, and they have said okay, we can take it is a constant space. Okay, but we have a better solution than the order of n squared. So let's see. So I hope you have got an idea also from the brute force approach that how we can solve it using the division operator. So let's see. So what we will do is, first we will find the product of all the elements of a given array. Okay, that is, we will find the 2 multiply 4 multiply 3 multiply 5 multiply 3. Okay, so multiplication of all the element is 360. Okay, now we have done this step, find the product of all element, that is 360. Okay, now we can use the division operator, okay, divide operator, to find the result. Okay, and we can fill in each of the boxes in the result array. How? We will say okay, at 0th position we will find the answer of 360, that is the product of all element, divided by 2. Okay, so 360 divided by 2 is 180, so 180 will be kept here. Okay, now at this position, what will be the answer? So product of all the element, that is 360. Okay, and divided by this ith element. Okay, this 1th element, that is 4. Okay, so 4 9s are 36, that is 90. Then here again 360 divided by this element. Okay, so it will be 120, right? 360 divided by 3, quotient is 120. And same way here 360 divided by this element. Okay, this particular element, if we are considering its third index. Okay, so 535 and 5 to 10. Okay, and same way here total product, okay, 360 divided by this element. Okay, 3. So again it will be 120. Okay, so this way we can solve this question, and we have used the division operator. Okay, now what essentially we have done is, when we are saying okay, find the product of all the element, that is we have found this in the first step. Okay, now at 0th index, when we are finding our resultant answer, what we are saying, we divided by 2. So if we divide this whole answer, okay, by 2, so basically we are saying okay, cut this and cut this. So what will be the remaining answer? 4353. 4353, product of all these elements, and this is actually we want, right? That is 180. Okay, then similarly at this position, what we are saying, product of all the element, that is this 2 multiply 4 multiply 3 5 into 3, that is all element, divided by this particular element, divided by this ith element. So basically we are reducing. Okay, we are reducing this whole expression in this way. Okay, we are cutting this 4. Okay, so now the product will be 2 3 5 3, product left will be 2 3 5 3. Okay, that is 4 is gone, so total answer will be 90. 2 into 3 into 5 into 3. Okay, so this way we are getting the answer. Okay, so this for loop is basically finding the product of all element, that is it will give me product as 360. Okay, and I have decided it with 1. Okay, and this is basically filling all these element one by one from 0 to last index, that is the 4th index. Okay, using the division operator, product divided by a of I, right? Okay, so now what is the time complexity of this question? So if we see, this is of order of n, and again this is also iterating from 0 to n. Okay, so this is also of order of n. Okay, so time complexity will be order of n, right? And space complexity, if we are considering this output array like also in the constant space, okay, then order of 1. Okay, but in this question we are said that please do not use the division operator. Okay, so now let's see without division operator how we can solve this. Okay, and before going further, let me tell you, if we use this concept only, okay, and some person can say okay, without using division operator, you are saying okay. So what I can do is I can actually change this expression in some other form, and I will not use the division operator. I will use the multiplication operator. So what actually we can do is we can use this concept, that is 1 upon some number is equal to x to power minus 1, right? Okay. So basically we can write in this form. And if we are writing in, let's say, the programming syntax, then x power minus 1 can be written as power of x comma minus 1, right? So basically when we are saying product divided by a of I, so basically it can be written as product multiply 1 upon ai. 1 upon ai can be written as a of I power minus 1. And this can be written as this, okay, power of a of I comma minus 1. Okay, so this whole expression can be written as product multiply power of a of I comma minus 1. Okay, so in this way we can say okay, we are not using the division operator. Okay, but basically we have just reduced this, okay, by our, you can say, some intelligence and common sense. Okay, now let's say interviewer asks you, okay, you are essentially doing this thing only, okay, please do not use this thing, tell me some another solution, okay, in which this you can say this concept or this concept is not getting used, okay, tell me the other solution. Okay, so now let's see the other solution. So in this solution we will use two extra arrays. Okay, so basically we have used the left array and right array, and this is our final result array in which we will store the final answer. Okay, so basically what we are going to do, let's understand. So as you know that, for example, if we have to fill this position, right, in the result array, so here the multiplication of all these elements, okay, all these elements has to be stored, right? When we are at the first position, this position, okay, then we have to leave this element, and we have to say okay, check the element at the left side of this 4, and check all the element on the right side of 4. Okay, so if we see, on the left side we have 2, and on the right side we have 3 5 3. So we have to find the product of basically 2, that is left side element, multiply all the right side element, that is 3 5 3 3 5 3. Okay, so this is the left element, and these are all the right element of 4. Okay, now if we are at here, then find the multiplication of all the left element to the 3, that is 2 4, these are at the left side, and find the multiplication of all the right element, that is 5 3, and then multiply these left and the right elements. Okay, or you can say left product multiply by right product. So 2 into 4 is the left product, and 5 into 3 is the right product, and then multiply this left and right product and store here. So this essentially we are actually doing. So now to perform all these things, we have taken two arrays, left and right. Left array will basically store the, you can say, left product of a particular ith element, or you can say prefix product. Right array will store the product of all the element to the right side of the ith element. Okay, or we can say it will store the suffix product. Okay, suffix means after, prefix means like before. Okay, so in this way, so you can say this is like a prefix array, this is like a suffix array. So let's understand, and then you will be better able to understand things. Okay, so here what we will do, we will first initialize the 0th element of the left and last element of the right as 1. Okay, I'll tell you that why we are actually doing. Okay, so basically now here what we will do is we will say we are at the first position, we are at the first position. So now here the, you can say, product of all the element to the left side of 4 should be stored. So what is at the left side of 4? That is 2. So basically there are no other elements, so basically 2 will be stored here directly. Now if we come here, then leaving this element, okay, what are the element on the left side of 3? Basically 2 and 4. So product of 2 and 4 should be kept here. Okay, so 2 multiply 4 is 8. Okay, so what basically we have done is 2 was actually stored here. Okay, so we can just directly say this answer 2 multiply this, okay, 4 8. Now here what we will store? We will say leave this element and find the product of all the element to the right side of 5. That is 2, 4, 3. Multiplication of this. Now we know multiplication of 2 and 4 is just before the third index. That is here. So we will 8 then multiply by this element. Okay, so 8 is basically the multiplication of this. So 8 3 is 24. Now here again leaving this element, find the product of 2, 4, 3, 5. Okay, so the multiplication of 2, 4, 3 is already here. That is 24. So 24 into 5, that is 120. Okay, so 120 is here. Okay, so I hope you have got the idea. Okay, so we are actually storing the prefix product. Okay, all the product of all the element to the left side of ith element, right? The same way we will do the right. Okay, we will do the right thing. Now before this, here as you see, I have kept 1. So how it was helping me? So basically when I was coming for the first time at the 1th position and I have to fill this element. So what I did, basically, I say, okay, here it is 1. So 1 I have said, okay, before this 1 was kept. So this was 1. Then to store this 2, I have done is 1 multiply this element. 1 multiply 2 is 2. This way I calculated the like this answer. Okay, and that's why I stored 1. Okay, I cannot keep it as 0 because in multiplication you can say identity element should be 1. Okay, if we keep 0, okay, if we keep 0, then something multiply 2 multiply 0 will be 0 only. Okay, that's why I kept 1. Okay, now here also, as this is the starting point, so I initialize it with 1. Okay, now let's find the right sum. So now let's start from this direction to this direction. Okay, so now I have to fill this position, that is the third position. So here what should I keep is leaving this 5, find the product of all the right side element, that is this. So 3 multiply 1, so basically 3 1 ja 3. Okay, so 3 1 ja 3. Now here what should be kept? Leaving this element, find the product of 5 into 3. So 5 into 3 is 15, right? 5 into 3 is 15. Now, what essentially we are actually doing is, we are saying, okay, 3 was kept directly here. Okay, so to find the 15, 3 multiply this corresponding element, that is 15. Now, if we have to find this, then just see, okay, leaving this element, find the product of all these elements, 3 5 3. Now multiplication of 5 and 3 is already here, so 15 multiply this 3, that is 45. And same way at this position, multiplication of 4 3 5 3 should be kept. So 3 5 3 multiplication of all these elements is already here, 45. So 45 into 4, okay, we can keep it here. In this way we have calculated the left product and the right product. Okay. So till now we have performed these things. Okay, so here we have said ki, okay, just initialize these element. Okay, that is left of 0 as 1 and right of n minus 1 as 1. Okay, that we can do. Okay, these are the corner cases. Now to fill all these positions, okay, left of I. Okay, so left of I will be the left of the previous element into a of previous element. Okay, so let's say if we are at this position, okay, we have to fill this this element, okay, at the second index. So what we are saying is, okay, my I is 2. So what you do, you go to the previous element, okay, in the left array, that is 2 minus 1. 2 minus 1 is 1. Okay, that means you go at this element. Okay, so this will be to multiply this element. Okay, so 2 minus 1 1, that is a of 1. A of 1 is 4. Okay, so 2 multiply 4, that is 8. So corresponding element are multiplied. 2 4 ja 8. Okay, so same for the right array. Okay, let's say if we are filling this position, so what we are saying, okay, if we are at 2, go to the next I plus 1 element, that is third index element, that is this 3. Okay, that is I plus 1 element. Multiply the a of I plus 1. Okay, you are at 2 now, so multiply this I plus 1 element, that is the third element, that is 5. Okay, so 3 multiply 5. 3 multiply 5. Okay, so this way we got 15. Now we have to fill this result array. So what we will do is, it is very simple. Okay, so now to fill this 0th element, what we will do is, we will just multiply this corresponding element, that is 180 into 1, that is 180. Okay, and what why we are actually doing is, let me tell you from here. Okay, so basically, to find the result of one element, I will multiply right of I element, that is 40, right of one element, that is one element 45, left one element, that is 2. So 45 into 2 is 90. Now, why we are doing it? So basically, as you know, to fill this element, okay, to fill this element, we do not have to like include this. We have to exclude this, and we have to multiply 2, 3, 5, 3. Okay, so basically, we have to find the left product, okay, and we have to find the right product, and then we have to multiply them. Right now, in the left array, we have already stored the left product. So this 2 is basically this 2. Okay, or you can say the product of all the element to the left side. This is 2. Now, what is this 45? This 45 is the product of all the elements which are right to the 4. That is 3 multiply 5 multiply 3. That is 45. Okay, so you can directly multiply 2, multiply this right product, 2 multiply 45, 90. Right? So this way, these left and right array are helping us. Now to fill this 2, what we will do? We will multiply 8 multiply 15. That is 120. So basically what we have done is 8 is the product of all the element to the right side of 3. Okay, so element to the right side of 3 are 2 and 4. That is 8. So multiplication of this is 8. And now all the element to the right side of 3 is 5 and 3. So 5 and 3 multiply, we got 15. So 15 is here. Okay, so basically we have multiplied 2 into 4 into 5 into 3, and we have excluded this element. Okay, so 8 multiply 15, 120. Right? And same way we can just multiply 24 into 3, that is 72, and here we can also multiply. Okay, that is 120 into 1, 120. So if you see here now, in this last position, what we have done is, as we have to find the to fill this position, we have to find the multiplication of all the element 2, 4, 3, 5, excluding this. So this 120 is the product of all the element to the left of 3, which is 2 multiply 4 multiply 3 multiply 5, that is 120. Okay, this is kept here. Okay, now to the right side of 3, what is present? Nothing. So we can just say 1 is present. Okay, so 1 is this element. Okay, 1 is this element. That's why we are saying 120, 120. Okay, multiply this 1, 120. Okay, so these are the corner cases that we have initialized them as 1. Okay, these were the corner cases. Okay, so this needs some, you can say, practice. Okay, you will solve some of the question and you will able to understand these type of things. Okay, so result of I is left of I multiply right of I. Okay, so I hope you have understood this solution. Okay, so what is the time complexity of this question basically? So you see, to fill the left array, we are actually running a loop. Okay, from let's say 1 to the last element, 1 to the n element. Okay, so basically this is of order of n. To fill the right array, okay, we are running a loop from, you can say, n minus 2th position. Okay, this has all the n element. This is the, you can say, n minus 1th position. This is n minus 2. Okay, so from n minus 2 to 0. Okay, so again this will run till n times. Now to fill the result array, we are running a loop from 0 to last. Okay, 0 to n. So again this is of n complexity. So if we add them, again we will get order of n time complexity. Okay, and the space complexity is what? Space complexity will be order of n. Why? Because this is taking one extra space, order of n. Right array is also taking extra space, order of n. Okay, and if we rule out, okay, if you remove the space taken by this result array, okay, as they have said in the question, you can like neglect the space taken by the result array, then also order of n plus order of n is order of n taken by these arrays. Okay, so I hope you have got the idea. Okay, now as they have said, can you do it without using the extra space? Okay, can you do without using order of n space complexity? Can you do using the order of 1? Okay, so let's see how we can do. Okay, so here we did not use any, you can say, division operator. Okay, but we have used the extra arrays. Now in the last solution, okay, I will show you that we do not need to use this left array and the right array explicitly, okay, as the extra space. We can directly make one array, okay, result array, and what we will do is we will find the let's say left product, okay, this left product in this array only, and with some modification, okay, we will find the right product also, and we will keep on filling this array, okay, one by one, but we will not explicitly make left and the right array. Okay, so in this approach, what is the idea? We are given this array, okay, and this is a result array, right? Okay, now we will not use any extra arrays, left and right arrays. Okay, so what I will do is, I will, let's say, store my left product, what we are finding in the previous solution. I will store that left product in this result array only. Okay, now you can store the right product also in this array. Okay, that depends. Okay, you can find anyone. Okay, so let me store the left product in this array first. Okay, so first step will be finding the left product and storing in this. Okay, so the idea is very simple, the same way. Okay, so here I will store the left product. So on the left side of 2, what is stored? Nothing. Actually, it is 1. Okay, I can say 1. So basically, I will initialize this as 1. Okay, as we were doing in the previous case. So, okay, this is the corner case. Okay, now to store here, what I will do is leaving this 4. What is there? 2. Okay, so 2 multiply 1 is 2. Okay, now here, what is the left product? So I will basically find the product of 4 into 2. Okay, so basically 2 is this. 4 multiply 2, 8. Okay, 8 3s are 24, 24 5s are 120. So this is my left product. Okay, now again I will modify this result array. Okay, and basically I will find the final answer. Now to find the final answer, what we did in the previous example, okay, or in the previous approach. So in the previous approach, we actually need the right array also. Okay, basically we have found the left array, okay, that we have directly stored in the, you can say, result array, but we need the right array also. Okay, so what I will do, I will not make any extra array. Okay, so here I have taken a product variable. Okay, this product variable will be storing actually the right product. Okay, right product, and how it will be doing is, okay, we will see. Okay, and this is very, like, you can say, good example where we can say, instead of taking the array, you are taking a simple variable. Okay, so let's see. So product is 1. Okay, so this is same like we were taking the extra, you can say, extra array. Okay, extra right array, and we were initializing the last element as 1. The same thing we have done here. Instead of taking the array, product equal to 1. Okay, you can see, like this way we have mimicked this right array. Now to fill this element, what we will do is, we will say 120. Okay, 120 is basically the multiplication of all the left element of 3. Okay, 120 multiply this product. So 120 multiply this product value is 1. So 120 multiply 1 will be 120 only. So here 120 will be kept. Basically 120 will be stored only. Okay, nothing will change. So basically this 1, you can say, this is actually the right product. Right product. So 1 multiply 120, 120. So this will not be modified. So basically this 24 is the product of 2, 4, 3. That is the left product. Now to find the final answer, I need the right product also. Okay, so where is the right product? 24. Okay, multiply 1, again it will be 24 only. Okay, so I cannot do this thing. So basically what we have to do is, when we were at this position, that is when we at this ith position, what we did is 120 multiply the current product, that is 121. 120 multiply 1 is 120. Now we have to make modification in this also. Okay, when we are going here, we want the multiplication of 2, 4, 3, that is 24 multiply 3. We do not have to include this. So 24 multiply 3. But where is 3? So basically when we were here, what we will do is, we will say, okay, 120 multiply 1 is 120, and now 1 multiply this 3. This should also be done at this position only. 1 multiply 3 is 3. So this is the right product. Okay, we are storing for the future use. Okay, now when we will come here, again we will repeat the same thing. Left product multiply this 3. 3 is basically the right product. Okay, so 24, okay, multiply 3. Okay, what will be the answer? 72. So now 72 will be stored here. Okay, now again when we will go here, we need the right product, which will be 5 multiply 3. So 3 is already here, so I will do product multiply this current element for the future use, that is 15. Okay, so when we will come here, we will simply say this answer multiply product. So 15 8 ja, okay, 120. So 120 will be kept. Now after modifying this, again modify the product. That is the right, which is storing the right product basically. So I will say 15. 15 is the product of 5 into 3. Multiply this 3. Okay. So 15 multiply 3, 45. So I have stored this product. Okay. Now when I will come here, what I will do, I will say 2. 2 is the product, this product, and this product variable is storing this 3 into 5 into 3. That is this answer. Okay. So here I will say 2 left into 45, that is 90. 90. So I have not included this thing, but I have multiplied this and this. Now again change the product variable, multiply this 4, that is 180. So 180 is basically the multiplication of this part. Okay, 180. Now I will come here and I will say exclude this. Okay, exclude this. Okay, so this one is basically this part, left part 1. Where is the right product? In the product variable, that is 180. So 1 into 180, which is 180. So here I will store 180. This is the resultant array, 180, 90, 120, 72. Okay. So you see how intelligently we have found the right product. Okay. Okay. We just use the result array to store the left answer. Right product is found out using the product, and on the fly we are finding the final answer. Okay. So we can see from this code snippet. Okay. So result of 0 was initialized as 1. Okay. Initially we kept here 1. Okay. After that we find the left product. Okay. We fill this thing. Okay. So we say okay, to fill this previous AI element and previous result I element. Okay. Both were getting multiplied to find the current result of I. Okay. And in this way we run the loop from I to n. Now after that we have to find the resultant array, that is the output answer. So we run the loop, okay, from this position to the last position and -1 to 0, and we were doing two things. First we were filling this. Okay, we were filling this how result of I multiply product, result of I, okay, multiply the product, and then we were changing the product variable. Okay, the previous product multiply the current element. Okay, current element. So to fill this, what we were doing is 120 was kept here. Okay, after this we were saying okay, previous product multiply number of I. Num of I is this element, so 1 multiplied 3 is 3. Okay, so num of I was multiplied, and in this way we were filling this, okay, from this direction to this direction and so on. After that we will return this, okay, result. Okay, so let's see in our IDE also. Here you can see I have made just one vector, okay, result vector. So my product is initially kept as 1. Okay, now my result array, okay, and then this is the left product and this is the output. Okay, so now if we submit this, okay, so the solution got accepted. Okay, so as we have not taken any extra array left and right, okay, we have just taken the result array, so the space complexity will be order of 1. Okay, because we are saying we are not counting the space taken by our resultant array. Okay, and time complexity is again order of n. So I hope you have understood this solution. So if you have any comment, suggestion, please write down into the comment box, and please do like and share this video. Okay, and let me know your suggestions also. So see you in the next video with next question. Till then, goodbye.